Hello everyone, today we're going to be going over quadratic equations. Before we start, I want to say if you do quadratic equations a different way, you can do them that way. You don't have to do them my way specifically because there are plenty of ways to get to the answer without doing it my specific way. Before we get too far in this though, let's go ahead and review quadratic equations. So quadratic equations, the normal form is ax squared plus bx plus c equals 0. Whenever you're solving these, they always need to equal 0. If there's anything on the other side of the equal side, you need to move everything to the same side. Every quadratic equation you can solve using the quadratic formula. I'm just going to write formula. But some of our problems are going to have us specifically factor them, and they're going to ask for the factored form. So if you've been using the formula, you'll have to go back to the factored form. I will be factoring all these, but just keep that in mind. Super squeaky. So the quadratic formula is a negative b plus or minus the square root of b squared minus 4ac all over 2a. You can solve every one of these problems using the quadratic formula, but if they ask for the factored form, you're going to have to put it into the factored form from this. I'm not going to use this till I get to the problems that specifically ask for this. There's different ways to solve quadratic equations that we're going to go over in this lesson, so let's go ahead and get started. Okay, so our first problem is x squared subtract 2x subtract 48. Every time I look at a quadratic equation, I think of it like as a story, and the story starts with what number is in front of x squared. If it's 1, then you're good to go. If there is a number in front of x squared, you try and factor that out first. Ours does not have a number here, it's just 1, so we go ahead, and since we have subtract 2x subtract 48, you go to this last number, this 48. I'm looking for numbers that multiply to get 48 but subtract to get 2. If you are not super good at your multiplication tables, you can list them like we're going to do right here. So I always go through, 1 goes into 48, 48 times. 2 goes into 48, 24 times. Does 3 go into 48? Yes, it goes in there 16 times. 4 goes into 48 12 times. 5 does not go into 48, so I'm not going to write 5 here. 6 goes into 48 8 times. 7 does not, and 8 does, but I already have 8 right here, so it would loop. So this is how I list my factors when I'm doing this. Now, every single one of these is a pair. It's married to the other, so you can't separate these. And I'm looking for which pair is going to subtract to give me negative 2. So 48 subtract 1 is 47. 24 subtract 2 would be 22. 16 subtract 3 is 13. 12 subtract 4 is 8, but 8 subtract 6 is going to give us 2. So we look here. We look for the numbers that multiply to give us 48 and subtract to give us 2. Now then, our last part of this story is it's a negative 2. Since it's a negative 2, I'm going to have a negative 8 and a positive 6. So this problem, they ask us to put it in factored form first. So this is where this negative 8 and positive 6 is going to come in, because I'm going to separate this to be its binomial form. So I have x subtract 8 and x plus 6. If I was to multiply this out, x times x would give us our x squared. Then I'd have plus 6x subtract 8x, which would give us our negative 2. And a negative times a positive is a negative, and 8 times 6 is 48. So this is your factored form of that quadratic equation. Right. This next problem, it's asking us to determine whether the statement is true or false. And we have the square root of x squared equals the absolute value of x. So every single math operation has an opposite operation. So the opposite of addition is subtraction. The opposite of multiplication is division. The opposite of a square is a square root. So if I take the square root of a square, I'd just have x. If I squared a square root, I would just have x. And then the absolute value of anything is its positive value, because the absolute value of something is a distance from 0. So we don't have negative distances. The absolute value of x would be x. So x equals x. This statement is true. The reason they have this problem on there is because we're going to solve some of these quadratic equations using the square root method later on. Our next equation is x squared subtract 9x equals 0. This problem doesn't have a constant. Remember the ax squared plus bx plus c? We do not have just the c value here. So this one, when we factor it, we don't have to find the numbers that multiply to get c and that add or subtract to get the b value. Here, we look at what can I take out of x squared and 9x. There's an x with both of these, so I could divide them both by x. So x squared divided by x would leave us with 1x here. Negative 9x divided by x would leave us with just negative 9 here, equals 0. They want the factored form on this problem and the solution, so right here is going to be your factored form. Then they want the solution set, so when you go to solve these, you take both factors and set them equal to 0. So we're going to have x equals 0 and x subtract 9 equals 0. This one's already solved here. The opposite of subtraction is addition. So we're going to have x equals 0 and x equals 9. They do not care on order yet. They start caring when we have like 4 or more answers. So for your solution set, you're just going to put 0, 9 in those braces. Number 4 is a lot similar, so I'm just going to do it over here. They give us x squared subtract 10x equals 0. So we do not have that constant value again, that's just by itself. So we're going to take our x squared and our 10x and factor out what we can. So x can go into both of those. There's an x with both. So x squared divided by x is x. Negative 10x divided by x would leave us with just our negative 10 equals 0. They do not want the factored form on this problem, so this is 4. And this one is 3 currently. So you take both of these and set them equal to 0 because they just want the solution here. And that's one of them here. Opposite of subtraction is addition. So your solution set here would be 0 and 10 in the braces. I can't draw braces. Okay. Our next question is z squared plus 8z subtract 9 equals 0. If you ever have one of these problems and it's a plus or a minus and it's one more or one less, it's always going to be this number and 1. So since we're reading this problem, there's not a leading coefficient, so we go ahead and look at our last number and we're looking for the numbers that multiply to get 9 and subtract to get 8. So our factors of 9 are 1 and 9 and 3 and 3. Remember, they're together. So which ones subtract to get 8? 9 and 1. Since it's a positive 8, you're going to have a positive 9 and a negative 1. And they do want this one in factored form, so we have z plus 9 times z minus 1 equals 0. This is your factored form. Then we'd set both of our factors equal to 0 to solve for the solution. So z plus 9 equals 0 and z minus 1 equals 0. Opposite of addition is subtraction. So z equals negative 9. Opposite of subtraction is addition. And z equals 1. Remember, when you put this into the solution set, you put the negative 9 and 1 into your braces at the bottom. Alright, the next problem is z squared plus 2z subtract 15 equals 0. So here our leading coefficient is 1, so we look at the back. We're looking for numbers that multiply to get 15, that subtract to get 2. So the first thing we need to do is list our factors of 15. So I'm going to do them right here. We have 1 and 15. 2 does not go into 15 evenly. 3 goes into 15 5 times. 4 does not go into 15. And 5 goes into 15 3 times. So out of these two, which ones subtract to get 2? 3 and 5. So we have a positive 2, so we would have a positive 5 subtract 3, because 5 subtract 3 is positive 2. They don't care if it's in factored form, but we're going to write it there. Z plus 5 and z subtract 3 equals 0, and then we would set both factors equal to 0 and solve them. One thing to pay attention to when they want the factored form, be sure you use whatever letter they give you. Sometimes, like when I was grading paper by hand, I would let them write with X instead of whatever weird letter they wanted to use this time, because when we're graphing, we always use X and Y. But that last problem we did, if you do not use Z when you type it in for the factored part, it's going to count you wrong. So keep that in mind. Next problem is negative 4a squared plus 16 equals 0. This one does have a leading coefficient, so if there is ever a leading coefficient or there is a negative with your whatever squared, x squared, a squared, you need to factor that out. So we are going to go ahead and divide this equation by negative 4. So negative 4a squared divided by negative 4 would give us a squared. A positive divided by a negative is a negative. 16 divided by 4 would be 4 equals 0. So we're going to go ahead, let me read how they want us to do this. They don't care about the factored form. So we're going to go ahead and keep factoring. Right here, it's the difference of two squares, which means that there's a square root of a squared, which is a, and there's a square root of 4, which is 2. So when we write this, I'm going to have a minus 2 and a plus 2. The big thing you have to realize when looking at these is that there's a square root of both of these. And just like before when I was saying, this would be the factors that multiply to get 4 and subtract to get 0. 2 subtract 2 is 0, so you just have to recognize there's a square root of both of these. Equals 0. Then we set every single one of these equal to 0. Does negative 4 equal 0? No, that's gone. A subtract 2 equals 0, and a plus 2 equals 0. The only time that negative 4 is going to come into play is if we are graphing, which we're not just yet. We'll start that in a couple chapters. And that would be that the graph is stretched by 4, and the negative would mean it's reflected. But we're not there yet. So our solution to this would be 2 and negative 2. We're going to start doing the reflections and stretches and stuff in chapter 3, I believe. And we'll also be using these factoring techniques to mark our zeros on our graphs. Right, next one is 3a squared subtract 147 equals 0. So we have a leading coefficient that's 3. This is positive though, so on this problem I'm just going to factor out our 3. And 3a squared divided by 3 is just a squared. 147 divided by 3 though is going to be 49. So just like the last problem, there is a square root of a squared and there's a square root of 49. The square root of 49 is 7, so I'm going to have 3a minus 7 and a plus 7. And they have to have opposite signs because when you combine them, it makes 0. So a negative 7 plus 7 is 0. And since they want the solution set on this problem, we just set everything equal to 0. 3 does not equal 0. Then opposite of subtraction is addition. Opposite of addition is subtraction. So our solution set is negative 7 and 7. Okay. Our next problem, x times x subtract 16 plus 63 equals 0. So the first thing we have to do when we have a problem like this is get it into the quadratic equation. Currently this one, we can't solve it because it's not distributed right. Or at least if we did solve it without distributing, it's going to have some extra steps. So x times x is x squared. X times a negative 16 would be subtract 16x. This 63 is not in the parentheses, so it does not get multiplied by x. So it's just 63. Now that we have this in the quadratic equation, we can factor it like we have been. So I need factors of 63 that add to get 16. So let's list our factors. We have 1 and 63. 2 does not go into 63. 3 goes into 63. 21 times 4 does not go into 63. 5 does not go into 63. 6 does not go into 63. Does 7 go into 63? 9 times 8 does not, and 9 does. So out of these factors, which ones add to get 16? This is the first problem we actually have had that has a plus sign at the end. Whenever there's a plus sign at the end, they both have whatever this sign is, because we're adding them to get this. When I add 7 and 9, 7 plus 9 is 16. But since it's a negative 16, I have to have a negative 7 and a negative 9, because negative 7 subtract 9 is negative 16. Tongue-tied. And then the negative times the negative would give us our positive 63. So negative 9x subtract 7x would give us our negative 16x. And then they just want the solution set on this one. So set both factors equal to 0 and solve. Opposite of subtraction is addition. If you've caught on, whatever the sign is between them, the answer is the opposite. That's why we call them zeros later on. That, and that's where they cross the x-axis. So our solution set is 7 and 9. Okay. Next, we're starting to solve a different way without factoring. I like these ways. But every problem we've done up till now, well, every problem we're going to do, you can solve with the quadratic formula. But you could have solved them using the quadratic formula. The big thing is just pay attention when you're doing this assignment to see what they want you to type in. Do they want the factored form first, or do they just want the solution? All right. Number 10 is x squared equals 36. And they tell us to solve this one using the square root method. So when we take the square root of both sides, you just have to remember that whatever is over here is positive and negative. So the square root of a square is just x. But over here, the square root of 36 is going to be a positive and negative 6, because if we squared a negative, I'd have negative 6 times negative 6, which would also be 36. So you have to have positive and negative 6. You can type it in just like this, or you can separate it to this. But this button, that positive negative, is one of your options that pop up on the bottom of my math lab. X subtract 2, and they have this squared, equals 9. You could multiply this all the way out and move your 9 over and still solve it how we've been solving the problems, or you can solve this using the square root method, which is what they told us to do, so we're going to do it that way. The big thing to make sure of when you're doing the square root method is that there is a square root of whatever is by itself. I can take the square root of this because everything is under or in parentheses together with that square. So we can take the square root of 9 as well. The square root of a square is just x subtract 2. And this is going to equal positive and negative 3. So I'm going to set one of these equal to our positive 3 and one of these equal to our negative 3. And then opposite of subtraction is addition. So I have x equals 5. Opposite of subtraction is addition. And this one is negative 3 plus 2, so it is negative 1. So my solution set here is 5 and negative 1. Okay, our next problem, don't freak out, there's a fraction. We have 1/3 h plus 5, and all of this is squared, equals 25. So since this is squared and there's a square root of 25, do the square root method. So when you take the square root of a square, we have 1/3 h plus 5. Remember over here, when we use the square root method, we have positive and negative 5, which is the square root of 25. Then I'm going to set one of these equal to the positive 5, and one of these equal to the negative 5. So then we solve them like normal. When I subtract my 5 to the positive 1, I get 0. So right here, since it's 1/3, this is, you can think of it as dividing by 3, and we're going to multiply it by 3, which over here, anything times 0 is 0. Then we're going to subtract our 5 over here. So we have 1/3 h equals negative 5 subtract 5 is negative 10. Then we multiply by our 3 over here. This becomes 1. Negative 10 times 3 is negative 30. So our solution set on this one is 0 and negative 30. Remember, with your fractions, the bottom is division and the top is multiplication. So to get it off the top or the bottom, just do the opposite. Top's multiplication, bottom's division. All right, next problem, they tell us to solve this by completing the square. If there's an easier way for you to complete these, you do not have to complete the square. You could just move it all to the same side and set it equal to 0. I'm going to show you completing the square, though, because you're going to have to use it in section 2.4 when we do circles. So if we were to complete the square with this problem, we take our middle term, our b here, and we divide it by 2. So 8 divided by 2 is going to give us 4. And then whatever is there, we're going to have to square that, because we're going to change this side right here to x plus 4 squared. We completed this square right here. But if we were to distribute this, the x squared and then 4x plus 4x, give me a second. So if we were to square this right here, because we completed our square using this and this, we're going to have x squared plus 4x plus 4x plus 16, which this makes the x squared plus 8x. This is what we had. So this new thing right here, this new 16, we have to add this to this other side as well. So this 16 that we found right here from completing this square, I have to add it to my negative 7. So we have negative 7 plus 16, which is going to give us 9. So we've completed our square here, and we can use our square root method now. This 9 came from adding these two. It's getting a little dirty on this one. Okay, so when I take the square root of this square here, we end up with x plus 4. Remember, when you do your square root method, you have a positive and negative. And then the square root of 9 is 3. So I'm going to set x plus 4 equal to my positive and x plus 4 equal to my negative 3. And then solve. So we have negative 1 here and negative 7 here. And that would be my solution set. Now, if you're just studying for this test specifically, this would not have been the way I would have solved this one. I would have solved it like my previous ones and set it equal to 0. But I wanted to show you completing the square before we get to circles later on and have to do it twice, because when you do circles, you have x squared and y squared. And you have to do both of them to get your center of your circle. Next problem. Use the quadratic formula. So first we have to write our equation. X squared subtract 2x subtract 13 equals 0. So real quick, our quadratic equation is ax squared plus bx plus c equals 0. So to be able to do our quadratic equation, we have to have our a, b, and c. So our a is 1, our b, over here it's positive bx since we have a subtract 2x, our b is negative 2, and our c is negative 13. Then we take this and we're going to put this into the quadratic formula. I'm going to write it back up here for us to look at. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, here we go. So we have negative b, our b is negative 2, plus or minus the square root of b squared, subtract 4 times a times c all over 2 times a. If you have a TI-30XS multiview, you can type this directly into it, but you'll have to do a plus and then a minus. It doesn't have the plus minus. And it'll give you the answer, simplified, radical, and all. I don't have a calculator on me. So a negative times a negative is a positive 2, plus or minus the square root of negative 2 squared is going to be a positive 4, because negative 2 times negative 2 is positive 4. 4 times 13 is going to make it positive. 4 times 13 is 52. All over 2 times 1 is 2. So 2 plus or minus the square root of 56 over 2. Okay, this is the part where if you have your TI-30XS, it would do this for you. This is probably the most confusing part for my online kids, is simplifying radicals, which you're going to do more of for the rest of the semester. If you have one of those calculators, it will do this for you. But when you have a radical, you have to check to make sure it's in simplest form. This one is not. You have to look for squares that go into this number. When I say squares, like 2 squared is 4, 3 squared is 9, 4 squared is 16, 5, 25, so on and so forth. 4 goes into 56. So let's do another tangent here. So we have 4 going into 56, 4 goes into 5. One time, 4 goes into 16. So 4 times 14 is 56. And if I take the square root of what I can, the square root of 4 would be 2 square root of 14. So we're reducing this square root of 56 to this because they are the same thing. So we have 2 plus or minus 2 square root of 14 all over 2. Now that's still not the final answer because all of these 2's. So 2 can be divided by 2, which is 1. 2 can be divided by 2, which is also 1, but this one's square root of 14. You cannot divide what's in the radical by 2, though, because it's like an x. It's kind of standalone unless it's the exact same as something. So the final answer that you would type into this problem would be 1 plus or minus the square root of 14. And like I said, if you have a TI 30XS multi-view, specifically that calculator, because if you have a TI 80 or whatever, anything up doesn't simplify the radicals. It's going to give you a decimal answer. But if you have those little blue ones, it will simplify this part for you as long as you type it in exactly like that, and it'll go ahead and spit this out to you. Okay. Find the real solutions, if any, using the quadratic formula. So we have 2x squared subtract 9x plus 9 equals 0. So we need our a, b, and c. Our a on this one is, a is always with x squared. B is whatever is just with x, and since it's not plus, it's going to be a negative 9. And c is 9. Now then, let's put these in the quadratic formula because that's how they want us to solve this one. So negative b plus or minus the square root of b squared subtract 4 times a times c all over 2a. And a is 2. There. And if you have your TI, you could type that into it. So a negative times a negative here is 9 plus or minus the square root of 9 squared is 81. Subtract 4 times 2 times 9. 4 times 9 is 36 times 2 is all over 2 times 2 is 4. 81 subtract 72 is 9. Square root of 9 is 3. Now I can actually do this problem because we no longer have a radical, so I'm going to have 9 plus 3 over 4, which would be 12 divided by 4, which gives us 3 here. And then I'm going to have 9 subtract 3 divided by 4. 9 subtract 3 gives us 6 over 4. This reduces, it doesn't divide though. 2 goes into 6 3 times, 2 goes into 4 2 times. So our solution set here is 3 3/2. The last problem says to use the quadratic formula. However, since there isn't a constant, I'm not going to use the quadratic formula because that's a lot of extra work on that problem. If you're using your calculator though, you could go ahead. It's easy. It's just there's no c. So our actual equation is 5x squared equals 9x. So the first thing you have to do, regardless of if you are using the quadratic formula, factoring, however you want to solve this, would be to subtract 9x to get everything on one side so that the equation's equal to 0. Now, if you went ahead and did your quadratic formula, you'd have your a is 5 and your b is negative 9. But since there's not a c on this problem, I think it's easier to just factor out an x. So you're going to have 5x subtract 9 equals 0, and then set these both equal to 0. Add 9. Then I have 5x equals 9. This is multiplication. The opposite of multiplication is division. So x equals 9/5. X also equals 0. So our solution set is 0 and 9/5.